Hello, I'd like to explain the friction experiment. Friction almost sound like a bad word because we want to avoid the friction. But as a matter of fact, friction is what pushes the automobiles to move forward. Well, this is the lab, so I like to focus on measurements of friction. So in this lab, we're going to use our spring scale, our sensitive, accurate spring scale. What you do is you are going to find a plastic container. In this case, it's a plastic bag. Um, and fill the plastic container with 100 grams to 150 grams of weight. You can just put your weight set, or you can just add different objects that has a certain weight and start to pull with the spring scale. And you can see on the spring scale at this time, it's being stretched when I'm trying to pull it. It's not moving yet. And here, this measurement will help us understand friction, both static and kinetic friction. And so this is how the experiment is performed. We're using a spring scale to measure the tension force. Well, this object is either at equilibrium, that is to say, it's moving at constant velocity or at rest, or it is on the verge of moving. So when it's on the verge of moving, it's a static friction. That is a little bit difficult to capture. So in this experiment, we like to use this to measure when the motion is in the pattern of equilibrium, either at rest or at moving at a constant velocity. So this is the friction experiment. This is how to perform the experiment. And when the object is at equilibrium, according to Newton's first law that applies to equilibrium, the tension force and the friction force are both on the horizontal direction. If it's at equilibrium, the sum equals to zero. So this tension force we are seeing as measured on the spring scale happens to be exactly the friction force. So when it's not moving at all, at rest, that's the static friction. When you are pulling the bag moving at a constant velocity, that represents a kinetic friction. So using this one setup, we can measure both the static friction when it's at rest or the kinetic friction when it's moving. Okay, so what about when it's between moving and not moving? That's what we call on the verge of moving. That we're going to use a different setup to perform. So that setup is what we call a slope. So in this case, we have a little wooden board. Instead of a wooden board, you can also use maybe a binder. Then put a toy on it or any object. What's really interesting is that we have tested and compared between a calculator and a cell phone. You know, cell phones are very slippery. Calculators have similar size and similar weight, but calculators don't break nearly as much as cell phones. So we want to perform a test instead of using Einstein as a little figure. We want to perform a test to find out the friction coefficient. So be very careful with your cell phone and be sure not to break your cell phone by doing this experiment. Calculators are usually okay. So put your calculators on it and do this experiment a few times. If you want to perform it with a cell phone, you need to be very, very careful and make sure you don't break your cell phone. So the experiment is you put it on the surface, and then you keep raising the surface slowly, slowly, slowly raising the surface until Einstein, or maybe your calculator, or maybe your cell phone suddenly start to slide. That's what when we call it on the verge of sliding. When you increase the angle slowly, the moment it starts to slide, it's really just start to slide very slowly. Okay, so that angle, I need you to measure it. To measure the angle, you use a protractor in your lab kit or you can also use a phone app to measure the angle, the slope. So I will put up a slide and you're going to see that this angle you measured, if you take the tangent function of this angle, that's exactly the static friction coefficient. So in this experiment, in summary, we performed in this lab, we performed two different experiments. First, we use a spring scale to measure either the static or the kinetic friction force. And then we use a slope. Use a binder, piece of wood surface, or we can use a ruler, for example, to measure the maximum static friction. And I will post the slides in the lecture part and some details to see how you perform the calculations. So this is what you do. We make measurements, we measure the angle for the maximum static friction experiment, and we measure the tension forces in the equilibrium pattern where it's at rest or moving at constant velocity. So that's the measurement.